Hello everybody, this is Dr. Christopher White, and in this video we're going to look at shale oil and shale gas. So in the previous video we were discussing a situation where we have a source rock, a mudstone, and that source rock is going to produce petroleum, oil and natural gas, and that oil and natural gas is going to rise into a permeable layer of rock which we refer to as the reservoir rock. However, what happens if that oil and natural gas cannot escape source rock? Well, it's going to become trapped in the and that oil and natural gas is going to be caught within tiny pore spaces within the source rock and within fractures within that. And the problem is mudstones have a relatively low permeability. So all those little pores within the source rock, they're not actually connected together very efficiently. And so that means that the oil and gas cannot easily get out of the source. So it becomes trapped within it. And so all of this oil and gas is just there in the source rock. It's not moving into the reservoir rock. And as such, until relatively recently, it could not be accessed. So when we talk about oil and gas, we typically refer to what are referred to as conventional plays. And these are the types of plays where we have a source rock, produces the oil and gas, that oil and gas moves into the reservoir rock, and it's trapped by a seal rock. And this is the standard model. And of course, the nice thing about these permeable reservoir rocks is once we drill our borehole down into it, because the reservoir rock has a good permeability, all those voids within it are all connected together, it means that when the oil is pumped out, it means it can flow along these, flow through the permeable rock into the borehole, and we can extract it relatively easily. In the case of a shale, on the other hand, the permeability is low, so all those pores within it are not connected. So we need to come up with a method that's going to allow us to open up a lot of permeability to allow that oil and natural gas to exit the shale and enter our pipe, enter our borehole. So how is that done? Well, that's going to be done using a process called hydraulic fracturing, which is also referred to as fracking. So in the case of fracking, what's going to happen is you're going to have a drill rig. You are going to drill a hole down until you intersect your oil-bearing or gas-bearing layer of shale. At which point, what's going to happen is you're going to turn your borehole and drill along your layer of shale. Now, one of the reasons that this type of unconventional oil and gas deposit was not accessible until the 1980s was because this process of being able to change the direction of your borehole wasn't really possible until the 1980s. Now, once you have your borehole and you've managed to turn it, so it's now running through your layer of oil or gas bearing shale, what you will then do is you will then pump down a mixture of high pressure water, sand, and other chemicals. And the pressure from this solution that you're forcing down your borehole is going to be sufficient to cause your shale layer to fracture. And this is going to open up the permeability that's going to allow the oil and natural gas to exit your shale and enter your borehole. And from there, it can then be pumped back out, recovered. Okay, so when we look at conventional versus unconventional oil plays, what are we looking at? So over here in the yellow square, we have a conventional oil play. So you can see we have an anticline, and you can see that the trap is forming in the hinge of. And you can see we have oil and natural gas deposits forming here, here, and also another one here. And you can see that these natural gas deposits and oil deposits are being accessed by this borehole here and another borehole right here. So the first thing you'll notice is that in order to exploit these particular traps, we actually end up needing two boreholes. So we need to drill two holes, we need two pads on which we will put the equipment to actually extract the oil and natural gas. And so we are actually putting a lot of equipment on the surface of the taking up space. Now, compare that to the unconventional play, our shale oil or shale gas borehole. So here's our pad where our drill rig is located, and you can see here is our borehole going down, and you can see there are several horizontal boreholes coming off that primary borehole. And each one of these is having this high pressure mixture of water, sand, and certain chemicals along it. It's causing these shale horizons to fracture, so that's our fracking process, and that's allowing the oil and natural gas to exit the shale layers into the borehole so it can be pumped back to the surface. So this diagram here actually gives you a slightly more close-up view of what's going on. So here's our pad located where all our equipment is located. Here's our primary borehole. Here is the borehole turning horizontally, and you can see there's the borehole, and these are all the fractures which are being produced by the fracturing. And once the fracture opens up, of course, we need to stop it closing because we need it to stay open to get the oil and natural gas out. And so that's done by both the pressure of the water, but it's also achieved using the sand, because the sand gets forced into the fractures which are produced, and it helps to hold them open, and it allows the oil and natural gas to exit into our borehole so that we can cover it. Okay. So this diagram there's a schematic that runs through some of the basic processes which are going to be taking place at one of these unconventional shale gas, shale oil plays. So here's our borehole again. You can horizontally to run parallel to our layer of oil or gas bearing shale, pump down our solution, which is going to cause fracturing. And essentially we're going to have a truck that's going to pump down the mixture of water, sand, and chemicals, or in some cases we're going to have a pump stationed on site, which is going to be constantly down that material, and that's going to come down our borehole, move horizontally along our borehole, and it's going to fracture our shale. The sand is going to stop the fractures which we form from closing up, and it's going to allow the oil and that gas to enter our borehole from where we can recover it. Now the gas is quite straightforward, it's very light, it's going to naturally rise, and we're just going to be able to pump the natural gas that comes out straight into storage. In the case of oil, obviously oil is a bit more dense, it's going to take effort, so there may be a pump on the surface which is going to help encourage the oil to flow upwards, but also due to the lower density of oil versus water, it will also naturally flow upwards as well. And so the oil and natural gas can be extracted, they'll be put into storage tanks. The water will then be put into a pit, essentially a pond, and the water that comes out can then be either used again, or it can be sent for treatment, and it can be cleaned up, and then it can be released back into the environment. So the nice thing about shale oil and shale gas is that it allows you to drill multiple boreholes from a single pad, and this is good because it reduces the footprint. It reduces the area that has to be disturbed in order to actually produce the oil and natural gas. So what you're going to have is you're going to have a situation where you have a central pad, and from that central pad you can drill multiple boreholes, and from those boreholes you can then drill multiple horizontal boreholes. And so each pad can have oil and gas coming from multiple different locations. And this is a schematic representation of what's going on. So you can see here, here's our pad where our rig is located and all other equipment require. And these are the boreholes coming off at one central borehole. So these are all these horizontal boreholes. And each one of those is for hydraulic fracturing of a layer of shale, and we're collecting oil and gas from it. And you can see here is an example of multiple pads located in an area, and these are all of boreholes coming off them. So you can see that shale gas and shale oil is actually quite an efficient way of extracting resources. But there are, of course, risks. Because you are pumping a lot of high pressure water containing sediment and, most importantly, chemicals into the subsurface, if you don't monitor correctly, there is the possibility that the fracturing can allow this water containing all these chemicals to exit your borehole and actually enter a underground body of water, which could be used for drinking water for a local bike community, for instance. So it's very, very important that the shale oil and shale gas extraction process is done to the highest standards possible in order to avoid any risk of contamination of local water sources. So, in terms of shale oil and shale gas, where is it extracted in the lower 48? Well, you can see that there are lots of oil and gas basins from which shale gas and shale oil are extracted. And these basins also contain conventional oil and gas deposits. But the great thing about shale gas and shale oil is that it allows us to essentially extract oil and gas from layers of rock which we would, until relatively recently, have not been able to obtain them from. And so shale oil, shale gas has essentially allowed the United States in particular to improve the amount of oil and natural gas that it produces itself. And that has essentially reduced its dependence on foreign sources of oil and natural gas. And it's turned the United States from a net importer of oil and gas to a net exporter. All right. Thank you for watching.